In this video, we will go through some questions from AMATS 2016, paper 2. So the first question we are going through will be for question 2. They state that for this expansion, over here we've got a quadratic and another one with power 6. The coefficient of x squared is 16. So find the two possible values for the constant p. So what we have to realize is that this term with power 6, it actually expands 1 minus px 6 times. So if you were to expand everything one by one, we'll get many terms. And a faster way will be to use binomial expansion. But the binomial expansion will give us 7 terms, since the power over here is 6. And we don't actually require all 7 terms. We are only interested in the x squared term. So when we keep in mind that our 1 minus 2x, that is squared, actually gives us 1 minus 4x plus 4x squared. Okay, that is for the first expansion. Consider for the second expansion, which are the terms that when multiplied to the first 1 minus 2x with a square can possibly give us an x squared. So the only way that is possible is if we have a constant term. Okay, because when a constant term multiplied by 4x squared, we do get an x squared term. The next term will be for x power 1, because when x is power 1 multiplied by negative 4x, we get another x squared term. As we continue expanding, the next term from your expansion of 1 minus px power 6 will be an x squared term. So the x squared term, when multiplied to the 1 in the first expansion, will also give us an x squared term. Then there is no reason for us to continue expanding and evaluating the subsequent terms in 1 minus px power 6 anymore, because we are only interested in the first 3 terms where we have x power 0, x power 1, and x power 2. Okay, so that is the plan, and we're going to carry it out now. So this is what we will write. 1 minus 2x with a square multiplied by 1 minus px power 6. Do the expansion, we have 1 minus 4x plus 4x squared. And here, the very first term, we have 1 power 6, which we don't bother writing. The next term will be 6 choose 1. Sorry, 6, yeah, correct, 6 choose 1. Okay, plus 6 choose 1, which we all know it is actually 6. Then 1 to the power of 5. Next, we have negative px power 1, which we don't bother writing also. And then for the third term, 6 choose 2 with 1 power 4. Okay, 6, 5, then power 4, which we don't bother writing also. Then negative px, this time it is power 2. And the expansion doesn't stop here, but we are not interested in everything else, so we just put a plus dot dot dot. So here, let us try to evaluate what our expansion gives us. 4x plus 4x squared. So next, 1 minus 6px. Okay, next is a plus. 6 choose 2 will be 6 times 5 over 2. So that's 3 times 5, we get 15. So negative px with a square, the negative, when you square it becomes a positive. We have p squared x squared plus dot dot dot. Now at this point, instead of fully expanding everything out, we can choose only to expand, to multiply those terms that will result in a x squared term. So we can then write x squared terms are, okay, so this is one way you can present x squared terms. That will be our value of 1 over here multiplied by your 15p squared x squared. So 15p squared x squared. That is our first product. We don't bother taking 1 multiplied by 1 because that doesn't give us an x squared term. So the next thing we are going to try will be negative 4x multiplied by negative 6x. So that gives us a positive 24px squared. And the last possibility will be our 4x squared multiplied by 1, giving us 4x squared. So the coefficient of x squared will be, the coefficient is 15p squared plus 24p plus 4. And in the question they tell us that it has a value of 16. So this becomes 15p squared plus 24p minus 12 equals to 0. We can divide by 3 throughout. 5p squared plus 8p minus 4 equals to 0. Now let us try to factorize. So we have 5p and p. We can choose 2 and 2 over here. So we have a total of 5p squared, 4, 10p, 2p. We want a positive 8p, assign the negative over here. So we end up with negative 4. We have 5p minus 2, p plus 2 equals to 0. And here we get two values of p. First, we have negative 2, or p will be equals to 2 over 5. Now in the next part of the question, they are asking us to find, hang on, for each value of p. So earlier on in part 1, we found that p is either equals to 2 over 5 or it is equal to negative 2. For each of these values of p, find the coefficient of x cubed. So let us try to write down the general term for each of these cases. Okay, so the r plus 1 term will be 6 choose r multiplied by 1 to the power of 6 minus r, which we know is going to give us 1 anyway. So actually, we don't bother writing that down. The next term will be negative px to the power of r. So since they are interested in the coefficient of x cubed, we know that the value of r has to be equals to 3, because that is the only way we can get a x cubed term. So when r equals to 3, we have the fourth term. So that will be 6 choose 3 negative p to the power of 3 and x to the power of 3. So what we have is the coefficient. We can extract the coefficient of x cubed is 6 choose 3. Since there's a negative, power 3 will result in a negative sign. Then we have p cubed. So this is the coefficient. Now for when p equals to 2/5, coefficient is negative 6 choose 3 multiplied by 2/5 power 3. So this gives us a value of negative 1.28. And when p is equals to negative 2, the coefficient, do the substitution, and we have 160. The next question we are going through is question 3 part 1. Now they give us a clue. Break cosine 3x into cosine 2x plus x. So one of the formula that we have learned is how we can expand cosine 2x plus x, or rather what we have learned is the expansion of cosine a plus b. So directly apply the formula, we will end up with cosine 3x 2x plus x. Here I'm just copying down the question, the suggested approach. So the first term we will have cosine 2x followed by cosine x. Then there is a change in the sign, sine 2x and sine x. Now we look at what they want us to prove. We do not have any double angles. So over here we have cosine x, over here we have sine square x. We don't have any two x's. So what we have to do is to apply the identity of converting 2x, cosine 2x in terms of either cosine x or sine x. Then we have to make a decision. Should I change it to cosine x or the form with sine x. So we look back at what they want us to prove. Cosine x is a factor, and we see that here already. Inside the bracket, we have sine square x, so it makes sense for us to convert our cosine 2x into the form of sine square x. So that gives us 1 minus 2 sine square x multiplied by cosine x, and over here sine 2x, there is only one expansion, which gives us 2 sine x cosine x, and now we multiply again by sine x, so we can conveniently square this. So we see that there is a common factor of cosine x in both of them. Factorize it out. What is left will be 1 minus 2 sine square x minus another 2 sine square x, which is simplified to give us what the question wants, cosine x 1 minus 4 sine square x. So since we have shown it already, put down in the bracket shown. So using this information that we have just found, we're going to attempt part 2. So even if you did not manage to prove part 1, you can still go ahead and use the expansion that they asked you to prove to help you solve part 2. Okay, that is the reason why they asked you to show, so that you will not get stuck. You can't do part 2 because you couldn't prove part 1. So here we have, they want us to solve 2 cosine 3x is 15 sine x cosine x. So let us compare this with what was shown in part 1. We had cosine 3x shown over here. So whatever I've just underlined can be expressed as cosine 2x plus x, or we can express it as cosine x times 1 minus 4 sine square x. Since they asked us to prove that, this is what we're going to substitute in here. So with the substitution we end up with 2 cosine x 1 minus 4 sine square x equals to 15 sine x cosine x. So let us subtract 15 sine x cosine x on both sides. We end up with 2 cosine x 1 minus 4 sine square x minus 15 sine x cosine x equals to 0. The reason why we are doing this is because I do not want to divide both sides by cosine x, because that will potentially cause me to lose some solutions. So from here on, we see that cosine x is again a factor, and we should factorize it out. Cosine x, after you factorize it out, we can do an expansion, 2 minus 8 sine square x. On the right hand side, what we have left will be our minus 15 sine x, and this is equal to 0. So now we have two options, either cosine x is equal to 0, or we have whatever is in the bracket here equal to 0. Now I prefer to have my coefficient of the sine square x to be positive, so I'm going to multiply everything by -1, and it doesn't matter because they're all equal to 0 anyway. So we end up with 8 sine square x plus 15 sine x minus 2 equals to 0. And this you have to recognize it is a quadratic, okay, which means that there is a possibility for us to factorize this, and indeed it can be factorized to become 8 sine x minus 1 sine x plus 2 equals to 0, which means that either cosine x equals to 0 or sine x equals to 1 over 8 or sine x equals to -2, which has to be rejected because the minimum value of sine x is only -1. So with all these, we can start to find the different angles. So from our cosine x equals to 0, you can sketch the curve, okay, and they told us they wanted the range of 0 to 360 degrees. 360 over here. For it to be 0, we've got 90 degrees and 270 degrees. X is 90 or 270 degrees. And over here, we have x. Find the basic angle for x. Sine inverse 1 over 8, which gives us approximately 7.180 degrees. And since sine is results in positive, we have our answers in the first and the second quadrant. So x will be 7.180, or in the second quadrant, 180 degrees minus 7.180. And after you evaluate, round it off, we get 7.2 degrees or 172.8 degrees to one decimal place whenever we are finding angles in degrees. So we've got 1, 2, 3 and 4 answers. Next question we're going through 6. So 6 part 1, obtain an expression for dy dx. Now what this over here simply means to differentiate this, and you will do so using the product rule. Okay, so after doing that, we'll find that dy dx is 8x minus 17 multiplied by 2x minus 5 square. Now I'm more interested in the second part because they want us to find the range of values of x, or rather the values of x for which y is a decreasing function. We have to interpret this as dy dx less than 0. When the gradient is negative, it means the tangent line is sloping down, and that would imply that the graph is actually decreasing. So we set dy dx to be less than 0, and we examine what we have over here for dy dx. So dy dx is made up of a product. We've got 8x minus 17 multiplied by 2x minus 5 with a square. Now for two numbers, when two numbers are multiplied together, we either have the result to be positive, negative, or equal to 0. In this case, we're interested in the product giving us a negative value. The only way that this can occur is if one of them is positive and the other is negative. So either 8x minus 17 is positive, followed by 2x minus 5 square is negative, or it has to be the other way around. But only one is possible, because 2x minus 5 being a perfect square is always greater than or equal to 0. It cannot be negative. Therefore, for the product to end up as negative, we only have one option, which is, from here, it implies 8x minus 17 must be the negative term. So from here on, we have x is less than 17 over 8. And that's it for part 2. Okay, next question 7, part 1. They want us to use this substitution, u equals to 2 power x, to substitute it over here and over here to form an equation in u. So we can see that, yeah, this is indeed made of 2 to the power of a combination of x. Likewise over here. So we have to manipulate whatever is on the left hand side and this term on the right hand side to be in terms of 2 power x. So let's start with that. 2 power 2x minus 1. On the right hand side, x plus 2 minus 6. So what this means is that we have 2 power 2x divided by 2 power 1. Okay, the laws of indices tells us that when we take 2 power 2x divided by 2 power 1, we end up with 2 power 2x minus 1. Okay, and on the other side, we've got 2 power x multiplied by 2 power 2 and minus 6. So over here, the objective is to make whatever we can in terms of 2 power x. So here we have 2 power 2x, which is not exactly 2 power x. So again, we try to isolate 2 power x, and our rules of our laws of indices tells us that, hey, actually if you square 2 power x, you get 2 power 2x. So over here, division by 2 is the same as multiplication by half. Okay, different way of representing it. So here we have 2 power x multiplied by 2 power 2 is actually 4, and we subtract 6 from this. Now we can do the substitution for 2 power x. So we end up with u squared over 2 equals to 4u minus 6. Continue to simplify. You can choose to multiply throughout by 2. You get u squared minus 8u plus 12 equals to 0. So this is the equation in u that we have to form. Hence, find the values of x for which this is equal to this. Basically, they are asking you to solve that equation in 7 part 1 that you have just formed. But after you have found the value of u, you have to substitute it back into the original substitution to solve for the value of x. Okay, so let's continue with part 2 on the right hand side. To solve u squared minus 8u plus 12, we realize that this can also be factorized to give us u minus 2, u minus 6 equals to 0. So we have two options, u either equals to 2 or u equals to 6. So here we use the substitution back again. 2 power x equals to 2, therefore x has to be equal to 1. Now on the other side, it is not as straightforward. 2 power x equals to 6. We will have to take common log on both sides, or if you wish to, you can take ln. So after taking log, we have x log 2 equals to log 6. X must be log 6 over log 2. Get the answer from a calculator, round it off to 3SF. So that's done. Finally, let's move on to part 3. So apparently part 3, we have to prove and explain why a different equation has no solution if k is greater than 8. Okay, so remember in part 2, we actually could solve a similar equation. But in part 2, they have minus 6. In part 3, it is a minus k. So when k has a value of 6, we could solve it. And we had the values for x. So when it is changed to k, we can actually use the same approach to try and solve it. And let's see what happens. So using the same substitution, using u equals to 2 power x, for part 3, our equation 2 power 2x minus 1, x plus 2 minus k will now become something very similar. We get u squared minus 8u plus 2k equals to 0. Okay, so this is a quadratic. And when we want to solve this, we can either choose to factorize or we can use the quadratic formula. By using the quadratic formula, we will have 3 possible cases. Either there are 2 real and distinct roots, or there are 2 real and repeated roots, or we have no real roots. In other words, no solution. And all these, they are dependent on the discriminant of your quadratic equation. So over here, let's figure out what the discriminant is. So the discriminant, which is b squared, negative 8 squared minus 4 times of a multiplied by 2k. The discriminant gives us 64 minus 8k. Okay, now when k is greater than 8, our discriminant will be 64 minus a number that is greater than 64. Okay, because when k is equal to 8, we get 64 minus 64, that gives us 0. But when k is a number bigger than 8, 8 times of a number bigger than 8 will be more than 64. 64 minus a number that is bigger than 64 will be negative. So the discriminant becomes less than 0. So since the discriminant is less than 0, therefore no solution. Now next one, question 8 part 1. To factorize fx, you will need to find a factor of fx first. Okay, and you can do so by using your calculator to help you solve the equation x cubed minus 3x squared plus 4x minus 12 equals to 0. So your calculator can solve this for you, and it will actually provide you with a value of x equals to 3. And there will be two other values which we are not interested in for this particular question. So since x is equal to 3, that is given from your calculator, we know that we can actually use the factor theorem to show when x equals to 3, f of 3 equals to, and then you do your substitution, 3 cubed minus 3, 3 square plus 4, 3 minus 12 equals to 0. So what we have done over here is to save a little bit of time, instead of doing trial and error for numbers such as 1, -1, 2, -2, and so on and so forth. Okay, so we realize that this is equal to 0, therefore we conclude that x minus 3 is a factor. So from then on, fx is going to be equals to x minus 3 multiplied by a x squared. Since fx is a cube, is cubic, the quotient after dividing by x minus 3 will be a quadratic. So plus bx plus c, and then you can do the substitutions to find the values of a, find the values of c. Alternatively, you can divide our fx by x minus 3 to find the same quotient. So that is the approach for part 1. In part 2, explain why it only has one real root. So the answer for part 1 is actually fx x minus 3 multiplied by x squared plus 4. So when this is equal to 0, x minus 3 equals to 0, or x squared plus 4 equals to 0. Which means that x squared has to be equals to -4. Now in our syllabus, this will be rejected because we are unable to find real numbers that when it is squared gives us a negative value. So therefore there is only one real root. The value is x equals to 3. So part 3, we have to find the constant k for which the graph of y equals to fx plus kx has a stationary point. So they are telling us that we have to differentiate. So dy dx, when we differentiate our fx, we get 3x squared minus 6x plus 4. And there is still a plus kx, so this gives us plus k. So this itself has a stationary point, which means that we have to eventually equate this to become 0. But they also tell us that dy dx, d2y dx squared also equals to 0. So let's do a second derivative. Dx squared, we get 6x minus 6. And this is equal to 0. So the only possibility is if x is equal to 1. Now what they are trying to tell us is that when we substitute x equals to 1 here and over here, our dy dx will be equal to 0. So we will end up with one equation with only one unknown. So 3 times of 1 squared minus 6 times of 1 plus 4 plus k equals to 0. And we can solve this quite easily. So 3 minus 6 plus 4 equals to plus k equals to 0. Therefore, k has to be equal to 7 minus 6 is 1. K is equal to -1. Okay, last question that we are going through. Question 9. This is actually shaded for you. Likewise over here. To find the gradient of the curve at A, simply differentiate and substitute in the value of x, which is 2/3. So the tangents to the curve are parallel. Find the x coordinate of B. Once you manage to get the gradient, which is found to be 1. Okay, that is from your dy dx equals to 3x squared plus 4x minus 3. We set this to be equal to 1. And here we have a quadratic equation which could possibly give us two values of x. Okay, so by solving that, we have 3x squared plus 4x minus 4 equals to 0. Do your factorizing. and we end up with x has a value of 2/3, which is given in the question, no surprise, and the other answer that appears is x equals to -2. So B has a x coordinate of -2. Now the next part, find the area, find the total area of the shaded region. Now you have to realize that the integration, the definite integral of fx, okay, or in this case of y, when we integrate x cubed plus 2x squared minus 3x dx, when we integrate it from -2 to 0, we are actually adding up all the y coordinates in this region. So all the y coordinates, they actually represent the height at every single point, and there are infinite number of points within this region. So by adding up all these heights, we are actually finding this particular area, and all these heights, they happen to be positive. Okay, so this integration from -2 to 0 will actually be a positive value. Now we compare that to the second portion. When I integrate from 0 to 2/3, okay, the same, okay, let me put it at the bottom. 0 to 2/3, x cubed plus 2x squared minus 3x dx. What we are doing over here is similarly to add up all the y values. However, all these y values are negative y values. So if I were to add all these negative y values up, I will have a negative answer. So this negative answer from this definite integral represents the area that I am shading now, but it has a negative value. Since the question wants the total area, they are not referring to negative area, because when we talk about area, it is a scalar, so it should be positive. Therefore, knowing that this gives us a negative value, we have to modulus it, and that is how we will arrive at the answer of 628/81 square units.